Hello everyone, welcome to AI Anytime channel. In today's video, we are going to talk about MusicGen, a new language model created by Facebook AI Research. Okay, so they have released this model, this last week only. I think they have released it yesterday only. Okay, and there's also a library, okay, that they have, created called AudioCraft. Okay, and we are going to explore that how we can now generate music with help of language model or AI in general. Okay, so this research had been done by Facebook AI or Meta AI. Nowadays it has been called as Meta AI, and their chief AI scientist Jan LeCun has also posted it on his social channels yesterday. So we're going to explore MusicGen, okay, the MusicGen single LM model that we're going to have. Okay, single stage transformer language model. Okay, and the results are promising. We are going to understand a little bit about the research paper and what kind of architecture they would have used, okay, to train this model. Okay, single stage transformer LM model that they call it, MusicGen. And we have to give credit to Facebook or Meta, whatever you call it, okay, Meta AI team. Basically, whatever happens with metaverse, okay, because Mark Zuckerberg was a little obsessed with metaverse. I think he still is. I'm not sure on that, but we have to give credit to Meta AI for the people like me and other developers and researchers in the AI community, because we are fighting against the closed source community or the closed source models. Facebook came up with llama models, which was like the breakthrough in the open source large language model community, and after that they have been releasing models like anything. They have came up with image bind, massively multi-language models. They earlier had NLLB for more than 200 languages. Then they come up with SAM, okay, segment anything model. So multiple models which have been released in the open source community. Of course, for that to get matured, it will take little time, but we have to give credit to Meta AI guys, because earlier I was not a big fan of Jan LeCun, because he was talking about auto-regressive models. But now I realize that I have to agree on that, the things that he has said in the past few months after the origin of ChatGPT, for example. And I now agree with most of his statements on the auto-regressive models and the large language models coming up, okay, and also the human intelligence versus artificial general intelligence that we are talking about. Now I believe on his statements, and I'm not a person who is strict with his judgment or the statement that we are making. I prefer to change my judgment or statement when I learn and study about those topics. So we have to give credit before we start this video to Meta AI in general, because they are doing a great thing to strengthen the open source community. Now let's jump in. So if you currently see, I am on this AudioCraft by Facebook Research, one of the most used GitHub repository, the Facebook Research, and they have AudioCraft. So if you read over here, it says AudioCraft is a library for audio processing and generation with deep learning. The state-of-the-art in codec audio compressor. They have multiple pre-processing techniques, etc., for audio analytics and processing, but we are more interested in MusicGen. So along with MusicGen, a simple and controllable music generation language model with textual and melodic conditioning. Very intuitive. I was going through their whatever paper that they have released, a technical report, whatever you call it. I really liked it, to be honest. I was going around it, I have studied it, and you can see they have given you the installation process. You need a GPU to run this. If you don't have a 16 GB of virtual RAM, you might not set it up locally. We'll use Colab in this video. We'll try Colab to see what kind of responses we are getting, what kind of music we are able to generate. And you can see they have 4 pre-trained models. Outstanding. So the small model is 300M model, 300 million trainable parameters model is there. Is small. Then medium, melody performs the best when it comes to, but you can read over here, right? 1.5 billion model, text to music and text plus melody to music. Okay, so if you have some reference melody example or samples, like your reference audio, like when I say audio, it's music basically, and you can also pass that as a reference, and you can use melody pre-trained model to perform inference on that. Then you have large 3.3 billion model. You need high virtual RAM to run those models. So you can see it's pretty easy to use the high level APIs. Again, we are using Torch as a backend, and then get pre-trained, and etc., passing the prompt like descriptions, happy rock, energetic EDM, sad jazz, for example. And then they have model card over here. You can see already here the model card. You can see I am on MusicGen small 300 million. They have given how to set it up, and they have given this inference code here. And here are the Hugging Face space. You can try that as well. And here is the Colab space. So we'll use Colab also. Now here comes the abstract. Here comes the paper. You can read over here, simple and controllable music generation. Okay, you can read it over here. And let me just open the PDF for you. And I was going through this paper, guys. I'll explain also in a very layman terms. I will try to explain about tokenization and greedy sampling, whatever that they might have been using in background. So model conditioning, how does this work. So we'll cover this in a very layman terms. Okay, so here is the library, here is the Colab notebook. So if you come to Colab notebook, they are cloning the repository, they are installing whatever needs to be installed, and then they are loading it using medium model device on CUDA, because we need GPU runtime to do this. And then you have some prompt and you are generating the audio. Now let's understand how it works, guys, right? So if you come over here in the abstract, you will say it says, so it's a single stage transformer language model, right, that operates on, if you read over here, that operates on compressed discrete music representation that's represented as a tokens, okay, in this model. So the model is trained on a large data set of music examples, allowing it to better learn the statistical pattern and dependencies in the music data. So you can find the abstract over here, to generate music based on a given prompt. So MusicGen, the model that we're talking about, employs a process called conditional generation. So the prompt that we will pass can be encoded into additional tokens. So we'll explain that through an example or a mathematical formula behind it, and provided as an input to the model. So the additional tokens with the prompt provided to the model as an input, and then this condition influence the model's output, allowing it to generate music that aligned with, you can read over here, with the specific characteristics, like you're passing jazz, you're passing some EDM, you're passing whatever you're passing in the prompt. Okay, so now let's understand this little bit on mathematically, that how it might have been working. So let me just make this a big so you can read. So I'll just try to cover the steps. So there are explain 5 steps that we are going to explain, and I hope you can see it here. So on steps, the first step, let's understand this, guys. So the first step is input encoding. So I'll just write input encoding. Now we'll take this prompt. So let's see what the prompt that has given in Colab. We'll take that example. So let's take the first description here. So let's call it what they have given, crazy heavy bang. So these are the characteristics. If you see this EDM and bang, these are nothing but the characteristics. Let me just write it over here. Sorry. So this EDM and bang that you see, so they are basically encoded into additional tokens, and then concatenated or merged with the initial music tokens. That's the first step, guys. Input encoding is the first step, and then we have the next step coming in. Okay, that's forward pass. So let me just first write all these steps. So the encoded input that we have, right? That's encoded input from the here that we have encoded input. So encoded input passed, and this is passed through a transformer language model. Okay, so this passed through a transformer language model. Now what happens here, which this transformers language model is consist of self attention, and so they are consist of self attention and feed forward neural network, guys. So if you are familiar with transformer models, you would have, at least you would have came across these terminologies like self attention and feed forward neural networks. So this self attention that you see here, right, this mechanism allows the model to capture dependencies of different tokens between different tokens. So we have multiple tokens over there, right? This helps us understand, captures the dependencies between all of these tokens, okay, in the music sequence. So helps captures dependencies between different tokens. That's the second step, guys. So the first step is input encoding, then we have forward pass, and then it comes the output distribution. This is very important for MusicGen model that we are talking about. Then we have output distribution. So what did our output distribution does, guys, right? It's basically a probability distribution. Okay, so let me just write it in to make it simple. It's a probability. So it's a probability distribution over the tokens. So the tokens that we have. So let me just write over the tokens from the previous stage, and then it is passed through a function. So this basically passes through a softmax function. And this softmax function applied basically to the model output logics. So we have model output logics. If you're familiar with transformer, you would have seen it across, right? Softmax function applied to the model outputs logic. Now that's the third stage. Now what we are talking in the fourth step is token sampling. Now this token sampling can be done using multiple techniques. Okay, so basically this token sampling is done for the next token. So for the next token in the sequence that we are going to get, okay, for next sequence for the next token, so there is a sampling strategy that has been employed. Okay, so that a sampling strategy, and now this can be done using two different techniques. Okay, in this case, so that can be greedy sampling, and the other can be top case sampling. So they have used top case sampling. If you go through the code also, okay, they are using top case sampling, etc. into when you read about, when you're passing the reference example. If you come over here on the Hugging Face, let me just show you. So this is the Hugging Face. But let's go into the files. When you go into the files, let's go to app.py. Now once you come into app.py, let's come down. You can see they are using a lot of things here: model, text, melody, duration, top K, top P, temperature, configuration coefficient, etc. So the more you read the research paper, you will understand that how the model has been trained, basically how they have created this MusicGen algorithm on a single stage transformer language model. Now this is not the end, guys. There is a last step that's very important for iteration. That's called iterative generation. Okay, after token sampling, you have to iterate until you get the desired maximum length, okay, of that sequence of music that you are generating in the end. Okay, so that's called iterative generation. So this is iterative generation. So this sampling process is repeated for subsequent steps. Okay, and with each generated token being fed back into the model as an input for the next step. Okay, so this is an iterative process until we get desired length. So let me just write until we get desired length. So these were very theoretical, guys, right? We are talking about here. Let me just go back. So we have input encoding, forward pass, then we have output distribution, then we have token sampling and iterative generation. So suppose, for example, if this architecture has been divided into these 5 steps, this is how I wanted to explain in layman terms, but this is more theoretical. Let's understand a little bit on a mathematical intuition of it. Okay, so let me just say, okay, now let me just write that again. Crazy EDM and heavy bass or heavy bang, whatever it is. Okay, so this is, for example, is your prompt. Now this music tokens are basically denoted by the sequence. So music tokens are denoted by the sequence. How can we denote this, guys? For just for the example, so let's call it x, and then we'll have x1, x2, x3 dot 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 goes to xn. That can be, so xi is nothing but the specific musical element. This is what xi is. So to condition this, now we have to condition this, to condition MusicGen on this prompt. So to condition MusicGen on the above prompt, on the above prompt, or the description, whatever you name it for now, on the above prompt, we can encode it as an additional sequence of tokens. Okay, so additional sequence of, I'm just writing additional tokens of sequence, and this can be denoted as P. So for example, P2, P1, P2, or that it goes to Pn. Okay, and then how do you combine this in, because you have to combine this input sequence to condition the music generation model that we have, right? In the training, while the training process. So the combined sequence, so the combined sequence can be denoted as P of P and X. Now this depends, right? During training, MusicGen learned to basically estimate the conditional probability distribution. Okay, to learn the conditional probability distribution. P of X and P. Okay, this is basically to generate music. Given the prompt. So mathematically, how do we write it? So we write it P of x1, x2 dot dot, and then P1, P2 dot dot. This is how we represent but this is not the final mathematical formula behind it. This is in a very layman terms that how we can come up with additional tokens, and then we have a combined sequence, and then how we can denote mathematically of this. So we start with prompt sequence P and iterative, so with P, and then iteratively sample token from the model's predicted distribution to generate the music sequence X. So this is how we denote this, guys. Okay, mathematically. So behind MusicGen, so this is an intuition behind it. Okay, this is what I wanted to explain theoretically and also with a mathematical intuition, that how it looks like. So it passes input there are 5 steps. If you divide it in a very layman terms, input encodings that encoded into additional tokens and concatenate with the initial music tokens. Okay, and then we have a forward pass that passes through a transformer model. Then inside that we have self attention, then we have feed forward neural networks that captures the dependencies between different tokens. Then we have output distribution. It's a probability distribution over the tokens, and then we apply the softmax function and on the model outputs logics, and then we perform token sampling for the next token. So this sampling techniques can be employed by different techniques like greedy sampling, top case sampling. Okay, and then we have iterative generation until we get the desired length of the music sequence. Okay, and then we represent it mathematically. So this was the mathematical intuition. I will give this screen grab in the description. Maybe you can refer to it later. Now here is the research paper. Please read it. I really like the research paper. It's very well written. Okay, and they have the sample music also. If you see the description, pop dance track with catchy melodies, tropical percussion and upbeat rhythms, perfect for the beach. Let's hear this, guys. Okay, so let me just see. Okay. So it's MusicGen. There are other models, MusicLM, Refusion, Mosaic. So basically MusicGen is the latest one. We have seen MusicLM, we have seen Refusion, we have seen other models as well. So there has been comparative study as well. And just for your information, MusicLM can right now generate up to 30 seconds if you have good infrastructure with you. But generally it generates 12 seconds of music for you. So you can see there have been some given some samples and comparison to other works also, guys. Music LA, and there are others also, so you can refer to it. Melody conditioning. Let's hear this. 90s rock song with electric guitar and heavy drum. This was the description and source of that sample, and then you have the MusicGen. So let's first listen to this. So it's a rock song, guys. Rock song melody. It's from 90s, which makes sense. It's sounds like that. Now let's see, after passing this description with the sample reference, how are we getting in MusicGen? Oh, it amplifies it, right? It sounds better, isn't it? It amplifies it, and we have long generation up to 2 minutes also they have done, okay. But I doubt that you will be able to do it. I think we will be able to do with a long model, and we need great infrastructure for that. So you can read about the abstract samples, comparison to prior work. Now let's run this, see how we can run it, guys. So it says I have to first reconnect it because we need GPU to it. So let's see how does it work. So we have to clone that repository, and then we have some classes and modules to import, and then we do from .get pre-trained. So if I see it's initializing the runtime environment for me. Okay, I'm on Google Colab, and if you have to check the GPU is already set. Okay, you can see the GPU has been already set by the default for this notebook. You can see Python 3 GPU T4. So there are A100 and V100 also, but they are for paid, guys. Colab Pro. So let me just save it. Okay, so it's allocating. It will not take much time. Again, I have saved it again. It's doing it again. And in the left hand side, you can see all the files. If you have mounted it, it will show the drive files as well. Okay, so let me just run this here. So it says this. Anyway, let's run this because I'm just using the same Colab notebook given as a sample. Now just imagine, where are we going with this technology, guys? So we already have Mid-Journey, Stable Diffusion, DALI, etc., which generates images. Then we have Runway 2, Gen 2 by Runway, okay, and Gen 1, Gen 2, which generates video. Just imagine, I don't see now that why would we not have a movie or a commercial ad. I think Coca-Cola has already done it. Everything end to end, the background music, the background score, and then we have the video, the frames, the images, the characters, the animes, everything generated by AI. And Hollywood people going on strikes in the United States are now make sense why people are little afraid or concerned that their jobs will be taken over by AI in the coming year. And I think that will be the case, or maybe the new job positions will be created, the job role will be changed. But there are some concerns, and I think those concerns needs to be catered, because I think those are valid concerns. Okay, now you have deepfake audio videos. Now we have this quality music coming in. Anyone now can have Shakira's voice or Kanye West voice, and they can have a background score and can create an entire music music video or a song or a rap right there, okay, with the help of AI. So, but anyway, that's not to talk about in this video. That's a debatable topic. Now we have installed it successfully. You can see it over here. Now let's export this, import this, guys. So what we're going to do here, we're going to importing Torch as a backend engine, and then we are getting the audio craft. So let me just do a refresh here in the left hand side, and you can see from audio craft, it will take a little time. So meanwhile, let's come back on this. We already on Hugging Face. Here you can describe your music and you can pass an audio. I'm not using this because currently it's suffering through high traffic and bandwidth, which makes sense. People across the globe are trying to use this Hugging Face space to generate, taking a lot of time, so I'm not doing that in this video. Maybe you can try it out, guys. So now this is done. Okay, so now if you see we have imported this successfully. Now what I'm going to do here, I'm just going to use medium device CUDA, and let's see what kind of music we generate with this. Maybe you can also change it to melody and see. So duration is 8. Let's keep it as default because it might take a little time if we increase it further. So let me just run this. Now once you run this will take little time, guys, because this has to get the model file, which is 3 point you can see it over here, right? 3.68 gigabytes over there. Let me just go back here on the guys, and let's see the thing over here. We have this model, 4 models that we have discussed: small, medium, melody, and large. And you must have a GPU. Without GPU, you will not be able to run this. Okay, so locally, if you have good VRAM, you may consider running it locally, and we can see that as well. So let's see. So you can see it's getting the model weights and files and everything that requires to inference the model. Okay, so it takes a little time. You can see now we are done. Let's have a default one and see what we are getting over here. Okay. Model.generate. There are some descriptions: crazy EDM, heavy bang, classic track with an electronic guitar solo, lofi slow BPM electro chill with organic samples. That's great description. I'm not a music guy. I have very limited expertise, in this domain that about all these terminologies. But people who are in music, they can utilize it better. I just wanted to, create this video so you can try it out, and what kind of mathematical intuition or what kind of steps they are using in the MusicGen model that they have created, the single stage transformer LM model they're talking about. So let's see, it's taking a little time. So what I will do, I may pause this video and I come back. Okay, we don't have to pause because we are getting the audio, guys, and it generates for all the descriptions. So we have here 5 descriptions and we have got 5 music there. Now let's listen to this generated music, guys. The synthesization can be a bit, but we'll talk because we are using the medium one. Maybe we can change it to melody and see also, but let's first listen to this. This sounds good. This is better because the first one with the crazy EDM, there was some distortions in that music, but this one was much better. So then we have lofi slow BPM electro chill with organic samples. Now let's listen to this. Yeah, it's slow and lofi. This sounds good. I'm so I'm getting excitement now and I'm really excited to create the next video, because I already have created videos on my channel using Bark and Tortoise TTS for custom voice. I can now just clone Justin Bieber or Kanye West voice, and you can use a background score to come up with some musical element into it. I don't see that as a challenge now, guys. Okay, to be honest. Let's listen to this. Rock, it's a rock with saturated guitar, a heavy bass line. Next 10, and I'm really happy with the responses that we are getting, guys, to be honest. Earthy tones, environmentally conscious, fantastic. Harmonic, this sounds much better. So I'm really happy with the response that I got, okay, to be here in this case. Now if you are interested more in having a voice samples and you want to pass your custom prompts and the custom voice samples and sorry, not voice samples, music samples, my bad. Okay, so music samples, so the melodies that you have, you can pass it over here. Sorry, I used voice samples because I have been using a lot of voice cloning video there, and that's why that came across in my mind. You can use this Hugging Face space. I'll give the link in the description, but it's also available on here you can see it says open in HF spaces. That's all, guys. This is what I wanted to create in this video. I wanted to explain a bit about the different steps that might have been used in this, but please go ahead and read the research paper also, guys. There's a research paper here, simple and controllable music generation, and by Meta AI, that's called FAIR, by the way, Facebook AI, that's the research team. And then abstract, then the previous example, comparative study, everything has been given. Okay, so that's all I wanted to do in this video, guys. I wanted to share this new trends also that's coming up in the AI ecosystem. I hope you like the video. If you like the content I am creating, if you have any kind of feedback or thoughts, okay, that my videos are not good, you can improve something, please let me know. I am open to feedback, and please drop your views or in the comment box. If you want to reach out to me, you can also reach out to me through social channels given in the YouTube banner. And that's all for today's video, guys. Please hit the like icon if you like the video, and if you haven't subscribed the channel yet, do subscribe. Please share the video and the channel with your friends and to peer. Thank you so much for watching. See you in the next one.